shared my screen. My screen is visible, Ji, to everyone. Okay, okay, Ji. Thank you for confirmation. Right, Ji. So yesterday we started this
सर अभी
topic
आपने
of
क्विज का क्या बताया? क्विज किस टॉपिक से होगा?
next week from IP addressing, inshallah.
ठीक है,
Okay, next week from IP addressing.
इंक्लूडिंग टुडेज लेक्चर.
Yes, yesterday and today's lecture. That's it.
ठीक है.
This is the topic. इसमें से quiz होगा. Quiz from this topic next week on Tuesday, inshallah. ठीक है?
सर वो
Okay, जी. जी,
क्रॉस
sure.
के अलावा जो बुक है जिससे आप ये वाला टॉपिक करवा रहे हैं वो अपलोडेड है LMS पे?
नहीं, बुक तो मैंने कोई भी अपलोड नहीं की. नो, आई हैव नॉट अपलोडेड एनी बुक, नाइदर क्रॉस एंड रॉस नॉर बहरोज फ्रोजन. ओके, you can find it by yourself on internet. You can find a PDF copy of Behrose Frozen and Cross and Ross both. I have not uploaded the books.
Okay sir, thank you.
Okay ji, you're welcome. The books are mentioned in the course outline as well. So if you just forget the name, refer back to the course outline. The book is Behrose Frozen, and the book title, I am so used to calling the books by their author's name that I sometimes forget the title myself. So I really don't remember the
So
title
data
of the book.
communication and networking.
Okay, data communication and networking. Yes, thank you. By Behrose Frozen. So you can refer to that book for the examples of IP addressing lecture. Okay, I have started recording. Yes. Okay, so let's start, Ji, once again. So yesterday we started this topic of IP addressing. I told you guys that an address is written in the form of dotted decimal notation, and it is assigned to each interface. So there is a common mistake that the students sometimes do, that they assign address to a host or to a machine, to a device. But in that case, they will be assigning one address to a router. That is not the case. Address is associated with the interface, not with the device itself. And then we started uh, two strategies, or two techniques of addressing. One was the classful addressing, which is not in use anymore in the internet. Now the classless addressing are used. But in classful addressing, we divided the address space into classes, and yesterday we discussed that. So we can just by looking at the first octet of the address, we can simply tell to which class it actually belongs, and this is the way of finding the class as well. We discussed the process of masking yesterday, and it's a very important process. The routers do perform these process quite often to extract the network ID from the destination IP address. So if a packet arrives at any incoming port of the router will just look at the destination IP address of the packet, and based on using that address, it will perform the process of masking with the default mask or the subnet mask, and then it will obtain the network address. Okay, by performing this process of logical AND. And according to that network address, it will look up the forwarding table and forward the packet to the appropriate port. There are many private addresses as well in the range. And we also discussed the process of subnetting yesterday. It is a process in which we divide an address into a manageable chunk which is suitable for our requirement. Okay, and we solved examples of a class B address by considering the example of NUST basically. So we divided the class B address of 141.14.0.0, and we assume that, let's suppose that NUST want to assign each and every device within its campus network a unique public IP address, and it has bought the range of a class B address 141.14.0.0 with the entire range, obviously 0.0 from up until 255.255 within the class B. And then we solved the example by considering that scenario. Okay, it was on the whiteboard right here. This was our example. Okay, 21 subnets, 13 schools. So we tried to do the networking of the Astral's campus. Okay, and then also we saw that the process of subnetting actually, without subnetting we have a 2-level hierarchy. With subnetting we have this 3-level hierarchy. Okay, and we are actually extending the ones of the mask. So the default mask is being extended. Okay, we saw two examples as well. For example, this is a class A address, and the subnet mask is the default mask is extended because the subnetting is being performed over here, and 10 bits are being borrowed, 8 in this octet and 2 in this octet. But anyway, the question was not this one. The question was that we want to find the destination network address, and if this is the destination IP address, then what will be the network address? And we perform this masking process. We took the IP address, we took the mask, subnet mask, and we logical AND it, and we got this this answer. This is the network address. Okay. And another example we did yesterday was this one. So in this example on the board, we solved a subnetting problem of a class B address. This is a class B address, and we took the example of NUST and we performed the subnetting, and these were the subnets designed. These are the subnet that we designed. Okay, for 21 no, sorry, not this one. These are the subnets designed. So subnet 1 will be from here to here, subnet 2, and this is subnet 3, and this is the last subnet, this right here, 141.14.248.0. So this is the 32nd subnet in the case of the example of NUST. And in this example, we have a class C address, which is this one, and the company needs 6 subnets, so we designed those subnets. Okay, we borrowed 3 bits because to design 6 subnets, we need to borrow these 3 bits from the host ID portion. Okay, and our new subnet mask becomes this because we extended the ones. Okay, in the default subnet mask we have 24 ones. We added 3 ones because of the 3-level hierarchy that we are creating by doing subnetting, and now we have 27 ones in the subnet mask. So this is our default this is our subnet mask. Okay, now the default mask, this is our subnet mask. Okay, and these are the subnets being designed over here. Okay, so the first subnet and the second subnet and then the last subnet, and obviously there are 5 more subnets in the middle over here. Okay, so this was a very brief recap of what we studied yesterday, and now let's move on to our second technique of IP addressing. And obviously I told you guys yesterday that classful is no longer in use because it leads to a huge wastage of IP address space. Okay, so the IP address space was not efficiently utilized if we perform the class full addressing. So instead, the addressing technique that is being used from mid-90s onward up until today is the siderized based IP addressing, and this concept is carried on in IPv6 as well. Okay, so the classless inter-domain routing is being carried on in IPv6 as well. So what is it? Let's start today's lecture from here onward. So siderized addressing or CIDR, classless inter-domain routing, it's the concept says that our address can be of the form this, okay, a.b.c.d/x, where x is the number of bits in the subnet portion of the IP address. Okay, x is the number of bits in the subnet portion of the IP address, which means that x is basically the number of ones in the subnet mask as well. Okay, so they are saying that you have 2 parts. You have a you have a prefix part, okay, which is represented by this x, okay, /x, and that is why we sometimes call it as a dotted slash notation as well. Okay, so it's written over here, slash notation, dotted slash notation, because we have dots in the middle and then we have a slash, and after slash this is the prefix. This x is the prefix. This x is the prefix. Okay, this x is the prefix. So, and then the remaining part is your suffix. Okay, so suffix can be easily calculated as, suffix is equal to prefix 30. Sorry, no, I'm wrong. I'm made a slight mistake. Suffix is equal to 32 total number of bits minus prefix. Okay, so if your x, which is your prefix, is let's say 22 bits, then your suffix, your host part, is of 10 bits. Okay, so 8 plus 2, this is the host part of 10 bits. Now, what advantage do we get by doing that? Okay, what we are basically doing is that we are uplifting the rigidity We are uplifting the rigidness of class full addressing scheme, and we are saying that there is no concept of classes. The whole IP address space is available, and you can have a subnet portion of arbitrary length. Okay, this is very important. You can have a subnet portion of arbitrary length. Okay, you just use slash notation, and that's it. You can have a subnet portion of arbitrary length. Okay, now in the previous world, if I may put it like that, I mean in the classful scenario, this 200.23.16.0, this used to be a class. Which class? A class
C.
a class C address.
Class
Okay,
C.
a class C address. And if this is a class C address, then basically we if we say that we have bought this class C address, if a sentence is that, just like this example, let's put this address in this example. Okay, if someone says that this is a company is granted a class C address, 200.23.16.0. Okay, this is not written. Okay, and then the question continues that immediately the first thing that comes into your mind is that my default mask is 255.255.255.0, which means that my host ID portion is this one, only this one. Okay, only this one, right? And this is my playing field. I will do subnetting, I will do everything within this last octet. Okay, but that's no longer the case. Now what we are doing, we are saying that this is an address, and we have a subnet portion of arbitrary length. Okay, so 200.23.16.0/22. Now /22 means basically what? There is one concept also which is called supernetting. I have excluded that lecture, but we don't need to go into that detail. But actually what we are trying to do over here is that we are actually /22 means what? /22 means that we are saying that the subnet portion is of these x bits. Now if we if this is the x, this is the prefix, this is the subnet part, then this basically translate into a mask of 22 ones and 10 zeros. Okay, this translate into a mask of 22 ones and 10 zeros. Now 22 ones basically means that we have the first octet as 255, the second octet as 255. In the third octet we have 6 zeros and then sorry, 6 ones and then 2 zeros, the third octet. Okay, 22 ones means these are this is 16 ones up until now. Then in the third octet we have 6 more ones and 2 zeros. Okay, so which basically means the mask will be 252. Okay, dot 0, something like that. So this will be the mask in this case. Now this basically means that instead of, in the classful scenario, if we are given this address and we have been provided with the statement that a company is granted a class C address. Okay, then obviously third octet is not our playing field. We move forward from here onward. Okay, but in this case, writing something like that with this address basically means that we have 10 bits in the host ID region, which basically means that 2 raised to the power 10 is the number of hosts, right? We know that this is the formula. Number of hosts is what? How many number of hosts? Number of hosts is 2 raised to the power number of host bits, right? Number of host bits. Obviously, for correctness, we subtract 2 because of the broadcast address and network address. But let's say this is something. So 2 raised power 10 is, 1024. Okay. So 2 raised power 10. So 1024 is the number of addresses. 1024 means that the total address range will be from 23.16.0 onward up until anyone? 23.16.0 up until anyone can tell me the total range? 200.23.16.0 up to anyone? 200.23.19.255. Okay, 1024 addresses. 1024 addresses means 4 class C addresses. So actually, by having this subnet mask of arbitrary length, we are doing what? We are allowing to have a subnet portion of arbitrary length, which means we can, we are in this case, well, in the classful scenario, this concept is called supernetting. We are combining 4 class C addresses: 23.16.0, 23.17.0, 23.18.0, and 23.19.0. 4 class C addresses means what? Every class C address has a last octet as number of hosts. Every class C address has 256 hosts. 4 class C address combined, this means 1024 host, and this is exactly the scenario we have. Okay, yes.
सर ये .19 कैसे आया यहाँ पे?
सर ये 10 भी बता दें। सर ये दोबारा ही समझा दें।
Which means के पूरा ही दोबारा समझा दें।
200.23.19.2555 इसका मैं पूछूं कि .19 कैसे हुआ, इसकी मुझे समझ नहीं आई।
Okay. Actually, okay, let me quickly repeat. This /x means that this is the portion of this is your subnet portion. Okay, this is your subnet portion, which can be of arbitrary length x. Okay. Now, if this is your subnet portion and we call the subnet part as prefix, then this means that your suffix, which is the remaining part, okay, your suffix will be 32 minus your prefix, because if this is x, then the remaining bit for the host ID portion, for the host part, will be 32 minus the prefix. 22 bits are for prefix, suffix will be 10. 2 raised power 10 means that you can have 2 raised power 10 addresses, 2 raised power 10 host, okay, which means 1024 addresses. Now, if you just add up 1024 addresses into this address, just add up. If you add up 1024 addresses, counting the 0 as well, counting 16.0 as well, you just add up 1024 addresses, this will be the address that will come at the very end, okay? Now, is that clear now or not? Okay, if we perform the same technique, the one that we performed, okay, ji.
Sir, do we have to change 1024 into this binary?
Yes, that's what I'm now going to do, so that you guys get a clear gist of what is happening. Should not be that difficult to understand, but no worries. Let me go into the binary just like I was doing yesterday. Okay, so 200.23.16.0/22. Okay, 200. No, sorry. 200.23.16.0/22. It basically means what? It basically means what? 200.23.16 is there, but actually, I mean, if instead of writing that, in fact, I should do something like that. First, let me again translate it into this one. This basically means 22 ones. Okay, ये बात तो सबको समझ आ गई ना? Everyone got this, right? This is the prefix. This is x, right? This is your prefix.
Yes,
okay, this is x. X is a subnet portion, and we know that subnet mask is created by putting ones in the subnet portion, and the host portion is all zeros, right? So basically 22 ones. I'm not going to write 22 ones, but 22 ones means 255. Zero. Now, if we carefully look at this portion, this is 1111110. Okay, these are host ID, and then onward this 0 is also host ID, and previously this 255 these are all subnet. This is all prefix 255.255, right? This is clear. Okay, now we know that the subnet portion is the one that is, you know, fixed. That is something that we cannot change. What we can change actually? What we can change is your host ID portion, right? Your host ID portion, what will be the limit of your host ID portion? What will be the limit? You know, 00.1234567 up until 11.1234567 right? This is your limit, okay? And now if you consider the binary of 16, okay, the binary of 16 is what? Anyone is going to tell me? Anyone is going to tell me the binary of 16?
301 and 30.
Okay, 301 and 1230. Okay, and
40.
40,
4
right?
zeros, sorry.
Yeah, 4040 1 2 3 4 5 6 7 8. Okay, so now in this case, these 6 bits are part of my net ID portion, so they will remain as same 000 100, and then the last 2 bits can move, these last 2 bits can move from 00.00000000 up until this one. Now if you translate this into decimal notation and this into decimal notation, you will get your answer, which basically means, and please note, before that we have 200.23. Before that we have 200.23. Now if I ask you guys, what is the decimal of this upper one? It is 200.23.16.0. And what is the decimal of this lower one? It is 200.23 dot, now this is 19. This right here is 19. So it is 200.23.19.255. Or and there is another easy way of saying that, because it's the prefix part is no, let's forget classful. Just stay in the classless. Okay. So this is the range. Okay. Now the benefit that we got, by this arbitrary length is actually what? We don't have to buy a class B address. I mean, I'm again using the word of classes. The classes are no longer here. But just trying to compare it with the previous scenario. If in the previous scenario, let's suppose a company needs 1024 addresses, what would be the solution? The company has to buy a class B address. But no, in this world, in the CIDR based addressing, this is no longer the case. It doesn't matter which address you have bought. You just, the thing that matters is the prefix length. This can be of arbitrary length, which means your prefix can be of any length like this, you know, /1, /2, /3, up until so on. Okay, any length. Your prefix can be of any length, right? And which means that depending upon your prefix, you know, your subnet mask will be created. Okay, so for instance, in our example, we just did something like that. Okay, /22, and our subnet mask was this one. Okay. And but it can be of any arbitrary length. Your prefix can be of any arbitrary length. This basically means that how many bits you are fixing in for your buying actually, which are fixed in your bought address, and how many are remaining in your host ID region, which is the one which is your playing field. Okay. Don't worry, if it is still unclear, I would like that you hold the questions and we go to the examples, and then if the questions persist, then I will definitely address all of them inshallah. Okay. So but
सर ये टेबल पेपर में दिया होगा, अगर खुदा ना खास्ता ये पेपर में आ गया सवाल,
खुदा ना ख्वास्ता अगर ये सवाल पेपर पे आ जाए, जो कि खुदा ना ख्वास्ता यकीनन ऐसा ही होगा, ये पेपर में जरूर आएगा. ओके.
पूछना था ये टेबल दिया होगा या
ये हरगिज नहीं दिया होगा जी, बिल्कुल नहीं दिया होगा. प्लीज डोंट माइंड, बट इस टेबल का मांगना बड़ी मुज़क्का खेज सी बात लग रही है मुझे. मतलब आपको इस स्लैश नोटेशन के साथ को कन्वर्ट नहीं कर सकते, ऑल वंस 18 वंस लिख के आप उसकी बाइनरी नहीं बना सकते. इसके लिए टेबल दिया होना चाहिए.
सर बन जाएगी, वैसे जरा जल्दी हो जाते काम ना.
नहीं आए, 3 घंटे होंगे आपके पास पेपर अटेम्प्ट करने के लिए. ठीक है, डोंट वरी. इन सब चीज़ों को मलूज़े खातिर रखा जाएगा पेपर बनाते हुए, कि आप लोगों को बाइनरियाँ भी क्रिएट करनी होंगी, जिसमें बहुत टाइम लग सकता है. अच्छा जी, जवाद ऑफेंड ना होइएगा। ये मुझे ज़रा थोड़ी सी मज़ेदार सी बात लगी है बेसिकली कि आप इस टेबल की ख्वाहिश करते हैं पेपर में।
नहीं
अच्छा
सर, वैसे पूछा।
अच्छा जी, ठीक है। नहीं, टेबल नहीं होगा यार, टेबल नहीं होगा। यू हैव टू कैलकुलेट इट बाय योरसेल्फ। अच्छा जी, सो बट यू हैव टू टेक केयर ऑफ दीज टू रूल्स, ओके? दिस इज important. When you the number of addresses in the block, they must be of the power of 2, obviously. These rules were there even in the classful scenario as well. We are dealing in binary, so definitely it must be in the power of 2. And the second thing is that the beginning address, this is something important in the case of siderized addressing, okay? The beginning address must be evenly divisible by the number of addresses, okay? The beginning address must be evenly divisible by the number of addresses, right? So for example, if a block contains 4 addresses, the beginning address must be divisible by 4. Let me give you an example. For instance, if I write something like that, 200.10.10. I don't know, 16 slash 30. यहाँ पे let's say I write something like that. Now slash 30 means that host ID, how many bits are in host ID region? How many bits?
2.
2 raised power 2. Okay, so 2 bits, 2 raised power 2, 4 addresses, only 4 addresses, right? If I have bought this block, I have bought a very small block. I have bought only 4 addresses. Now 4 addresses means that my total address ranges from 10.16 up until 10.19. I have only bought 4 addresses, and the beginning address is 16, and it should be evenly divisible by the block size, by the number of addresses. The number of addresses is 4, 16 is evenly divisible by 4, this is right. If I write something like that, 200.10.10.16/28, in this scenario, how many host bit I have? No, /27. I want to give a wrong example. 5 host bit. 2 raised power 5 is 32. Okay, 16 is evenly divisible by 32. Beginning address is evenly divisible by the size of the block. No, it is not. So this is a wrong thing to write in siderized. This is wrong. Okay, so the number of addresses must be in the power of 2, and the beginning address must be evenly divisible by the number of addresses. Okay, right? So this is important, the second thing, and you have to take care of these two rules when you do the siderized addressing. Okay, now without any further delay, let's start looking at the examples, and you guys will help me in solving them. Yes, please. Question?
Sir, can you repeat the last point?
Okay, the last point will be repeated in the examples as well. So let's continue with the last point. The last point was that the beginning address must be evenly divisible by the number of addresses. So I have example 1. All examples are taken from the book of Behrose Frozen. Which of the following can be the beginning address of a block that contains 16 addresses? Right, which of the following? Okay, so you guys will solve it. Which of the following can be the beginning address of a block that contains 16 addresses?
32 and 80. A and C.
A and C. A and C are the right answer. Good. You are right. A and C are the right answer, because now again back to the rule. I will answer your question as well. The one who asked the question, I think Zainab, that two rules. Number one, the rule number 1 is that the number of addresses must be in the power of 2. Okay, we are already given 16 addresses. 16 addresses is already a power of 2. Okay, and the beginning address must be evenly divisible by the number of addresses. The beginning address, this is the beginning address. This can be a beginning address. Can it be? Is it right? 32 is evenly divisible by 16. Yes, it is. It's the right option. 44 is evenly divisible by 16. No, it is not. It's the wrong option. 80 is evenly divisible by 16. Yes, it is. 52 is not evenly divisible by 16. Okay. Is it clear now to everyone? Have I answered the question? The address 32 is eligible because 32 is divisible by 16, and the address 80 is eligible because 80 is divisible by 16, and we only have to look at the last octet. We only have to look at the last octet. We don't have to look at the third and the second and the first octet. Why? because the size of the block is smaller than the last octet. If the size would be greater than 256 addresses, if the size is greater than that, then we have to check the last two octets for even divisibility. Okay, ये बात समझ आ रही है सब लोगों को? Everyone get this point?
Yes, sir.
Okay, this is our rules. Number of addresses in the block must be of the power of 2, and the beginning address must be evenly divisible by the number of addresses. So the number of beginning address, how much portion of the beginning address to consider? How much portion? Well, it depends on the total number of addresses. If the number of addresses are smaller than one octet, so one octet can have at most 256 addresses, right? The outermost octet can have at most 256 addresses. If the block size is smaller than that, you don't have to look at the first three octets. Just check the divisibility constraint on the last octet. Okay, so 32 and 80 are fine. The 44 and 52 are not fine. But for example, example 2, if we look at the example 2, which of the following can be the beginning address of block that contain 1024 addresses? 1024 addresses. Okay, now in this case, how many host bits are required for 1024 addresses? How many host bits?
10.
10 host bits. Okay,
10.
Which means that the last octet alone is not sufficient. The last octet alone is not sufficient to check the divisibility constraint. You have to check the last two octets. Okay, the last two octets. You have to check the last two octets. Okay, the third octet and the fourth octet. Okay, so I have to stop for one thing. It is bothering me. Jawad, you are here?
Yes, sir.
Okay, I'm sorry if you get offended from from my jokes.
No,
from
no,
my
sir.
mazak, okay?
No, sir. No,
Okay.
no, sir. ऐसी कौन सी बात है, sir?
Okay. Let's move forward. वो just मुझे थोड़ा सा funny लगा, इसलिए मैंने थोड़ा सा मजाक कर दिया. Okay, let's move forward. Yes, now tell me, in this scenario, how will you check the divisibility? One way is that you write the binary, the total binary. You write the binary of third and fourth octet, 37.32. You write the binary 42.0. You write the binary 32.0. You write the binary 24.52. You write the binary, and then you divide it with the binary of 1024. That's a very long way to do that. Okay, the short version, if you want to do it by staying in the decimal, how will you proceed? To be evenly divisible by 1024, definitely the last octet should be 0. Okay, so if you want to stay in decimal and want to solve it, these two are immediately wrong answers, because the last octet is not 0. Okay, to be evenly divisible by 1024, this is greater than how many addresses can have in one octet. So to be evenly divisible by 1024, the last octet should be 0. So one of these two can be the correct answer. Now we know that there are 10 bits. 10 bits means that 2 bits are from the third octet, and the remaining 8 bits are from the last octet. Now the last octet should be 0. Okay, but 2 bits means that the third octet, okay, the third octet should be evenly 2 bits mean 2 raised power 2 4. So the third octet should be evenly divisible by 4, which leaves us only with this option. Okay, and that's what is explained over here. Okay, to be divisible by 1024, the rightmost byte of an address should be 0, and the second rightmost byte, which is the third octet, must be divisible by 4. Only the address this meets the condition. Okay, otherwise the longer way to do it, which can be a more proper way to do it, is that you write the binaries of everyone, each and every of these numbers. At least you write the binary of the last two, okay, last two octets over here, and then you divide it with the binary of 1024. It will take long, but trust me, if you have the number of addresses greater than one octet, definitely the last octet should be 0, the decimal, and the previous one should be divisible by the number of host bit in the third byte, which is 2. 2 raised power 2 is 4, so 32 divisible by 4 should be the case. 42 is not divisible by 4, 32 is. So this is the right answer. Okay. Right, Ji. Next example. Please solve this. A small organization is given a block with the beginning address and the prefix length this. Now you have to write the range. Okay. Please do it yourself. You must do it yourself. Okay. Not only within the lecture, but after the lecture, when you want to practice subnetting, you want to practice the IP addressing. Go to internet, have a look at examples, open your books, and solve examples. Have a look at different examples. It is very important. Practice is important in this particular topic. Okay. Right, Ji. So this one, please go ahead and solve this one. A small organization is given a block with the beginning address and the prefix length this. What is the range of the block? Anyone? 205, 16, 37, 24. Two 205, 16, 37, 24. So, range. Easiest way to calculate range is what? Easiest way. This is your prefix. Your suffix will be what?
32 minus 29.
3 हो जाएगा sir.
3, which means that the number of addresses in this block, the number of addresses are
8.
8 to the power 3, 8. Easiest way to calculate is that you just add 7 over here. Okay, so the block range will be 205.16.37.24 up until 205.16.37. You add 7 and you get what? 31/29. Easiest way is this one, because I mean it's clear. It's clear that the number of bits in the suffix region, which means the number of bits in the host ID region, is 3. Okay, and 3 means 2 raised power 3 is the maximum number of addresses in this block. Okay, or 2 raised power 3 is 8. Now dot 24 is included, so you add 7 and you get dot 31/29. Okay, and the other way around is that you write the binary just like we did yesterday, and just like what is did in the solution of this one. Okay, you write the binary. You have written the binary. This is 205.16.37.24, and then you have the last 3 bits, so it can take the range from 000 up until 111. And if you convert this, the beginning one, this is dot 24, and if you convert this, the last one, this is dot 31. Okay, so there are only 8 addresses in the block. But I think we have done enough practice, so we can, leave the binary thing, and so now we can try solving things in just by just staying in the decimal. Is this clear to everyone, Ji? Is this clear to everyone?
Yes, sir.
Okay. Now again, start comparing and start understanding the difference between siderize. What is the benefit that we are getting from this arbitrary length subnet? You see, this is a class C address. In the class full environment, imagine a small organization which only requires 8 addresses. In the class full environment, it has to buy one entire class C address, 205.16.37.0, maybe something like that. But here, it is buying a block as per demand from within the class C address. This is 37.0 continued. And the class C address 37.0, it will go from 37.0 to 37.255, and we have 205.16 behind it. Okay, so this is the entire class C address. This is the entire class C address. Now in the arbitrary length, now since we have the subnet portion of arbitrary length, this is the luxury, this is the leverage that we get. Okay, we can assign addresses, although still we need to follow the 2 rules. The 2 rules are that the number of addresses must be in the power of 2. 8 addresses is the power of 2. We are fine. And the beginning address must be divisible by 8. By the size of the addresses, we are again fine. Okay. This is evenly divisible by 24. 8 3s are 24. So we should still follow the rules, but arbitrary length means we have this luxury. We can easily allocate the size, the block size as per our requirement. Okay, so moving on, next example, please solve this one. Now this requires you to perform the process of masking. What is the network address if one of the addresses is this? Okay, one of the addresses. You have a block, आपके पास block है, and block में से एक address pick कर लिया गया. Okay, you have just someone has just picked one address from the block. Okay, now the block has an entire range, starting address, beginning address, and ending address, but someone has just picked one address in the middle of the block. Okay, and by just looking at this one address, can you tell the network address? Yes, you can. So please go ahead and calculate it. 167.199.170.82/27. Okay, 167.199.170.82/27. Okay, this is the address. Can you tell the network address? Yes. So /27 means my subnet mask is 27 ones. So 255.255.255. Anyone has calculated? Dot.
Two to four.
बिल्कुल ठीक, correct, 2 to 4. And I will do what? I will simply do the logical AND. So this is the address right here. I will do logical AND with the subnet mask 255.255.255.224. And after doing the logical AND, you can do it by yourself. The answer will be 167.199.170. Because the first three octets will be just copied because they are logical, they are being logical AND with all ones, all ones, all ones, all ones. So it will be 167.199.170.82 and 224. You will write the binary up and down, and then you will do the logical AND. The answer will be 64. Okay, the answer will be 64. Is it okay, Ji? Everyone agrees?
Yes, sir.
Okay.
Yes, sir.
Right here. Okay, 64/27. You must write, always write with each and every address. You have to write dotted slash notation. Okay, so the correct way to do is this. Okay, /27. Now if I may ask, what will be the range of this network from .64 up until
.96.
not 95,
Plus 30.
plus 31. Yes, plus 31. Okay, because 2 raised power 5 is 32, 64 is included, so we just add 31 over here. Okay, and this is 167.199.170.95/27. So this is the entire range, okay, of the network. Right, G, clear? How much time do I have? It is 50 already. Okay, I knew it at the beginning of the class that I will never be able to complete it. But anyway, I encourage you guys to have a look at this example. I really encourage you guys. Okay. Okay. In that case, obviously, we will have quiz on Wednesday, not on Tuesday, because I will conclude, or maybe we can conclude the topic on Tuesday and then have quiz after the topic. So in this case, I will have your undivided attention at the beginning of the class on Tuesday. Yes, this is what I'm going to do. Okay, so we'll have a quiz. I encourage you guys to have a look at the example 5. Okay, this is the example, right? And ISP is granted. This is one proper example. Okay, ISP is granted a block of addresses starting with this. I encourage you to do it by yourself. Trust me. Don't look at the solution. 1, 2, 3. These 3 slides is the solution. 4 slides. Okay. Don't look at the solution. It is not difficult. It is very easy. Okay. I will go through this example on Tuesday, but I really encourage you that you try to do it by yourself. You will allocate the addresses to first group and then to second group and then to third group. Okay. Okay. You will design the subnets. you will give the dotted slash notation of each subnet, and you will find how many addresses are left after the allocation. So this is the range 190.100.0.0/16, and then you have the ISP. This is the address block bought by the ISP. So for instance, Neatel has bought this block. So the range is from 00 up until 255.255. 2 raised power 16 addresses are there. You have to divide these 2 raised power 16, 65,536 addresses into these 3 range of customers. Okay, so let's say there are 64 customers, means 64 companies who contact Neatel in blue area, Islamabad. There are 64 companies, and these companies are requires 256 addresses, and they contact. So you need 64 subnets of 256 addresses. Then you need 128 subnets of 128 addresses, and then you need 128 subnets of 64 addresses. Okay, so you will do this allocation in 3 steps, and then you will find the answer, and then you will find the how many addresses are remaining by subtracting from 2 raised power 16 minus everything that you have allocated over here. Okay. Okay. Don't worry. I'm not getting rid of it. I will go through it. But I really encourage you that you go through it by yourself. I will stop recording now. On Wednesday we have really